Lab 3 investigated the relationship between the position of a star rotating around a black hole and the components of net force acting on that star. Using the relationship between the change in momentum and net force, explained by Newton's second law, the overall net force, as well as the parallel and perpendicular components of the net force of the black hole acting on the star, were determined. Using the net force calculated, the unknown, the mass of the black hole, was determined. To model the situation correctly, first the information about the star's and black hole's initial position was entered into the code shown here. The mass, gravitational constant, and delta t were also plugged in to be used later in the while loop that will update the star's momentum based on the position and these values. Using the imported position data, values for velocity were calculated over each increment of delta t and stored to be used in the calculation while loop below. To find the overall net force, the calculated change in momentum over change in time was used. As shown here, the initial velocity and final velocity were calculated to determine the initial and final momentum, and from there the change in momentum, defined as delta p. Using the relationships shown here and Newton's second law, the value for dpdt was set equal to Fnet. To calculate the parallel and perpendicular components of the star's momentum, the initial momentum value was plugged into the equation for the parallel component of the change in momentum, as shown in the code here. Knowing the relationship shown here, the values for the net change in momentum and the parallel change in momentum previously determined were used to calculate the perpendicular change in momentum. These components of momentum were plugged into Newton's second law to obtain the components of net force, which were graphed as the code was run. The force that the black hole imposes on the star is a gravitational force. So solving this equation, with r being the difference in position between the star and the black hole, the unknown value, the mass of the black hole, was determined. It is important to note that it was possible to calculate the perpendicular component of the change in momentum based on the other components of the change in momentum. However, the same methodology cannot be used for the net force because, as stated here, the sum of the parallel component of the net force and the perpendicular component of the net force is not necessarily the overall net force. Assuming that the star has the same mass, position data, and that the only net force acting on the star is the gravitational force, it is not possible to calculate a mass of a different black hole with this information.